Hello, I'm Russ Williams, and I'm a cloud solution architect working in the national practice of the Customer Success Organization here at Microsoft. I'd like to take a few minutes to talk to you about something we call conversational AI. I'll explain what it is, why it's super valuable, and how it can be used in transformational ways in your organization. For some of you, this may be a new and somewhat vague term, so let me explain. Now, if you think about it, the ability to talk to things is actually rather commonplace today. I can talk to my thermostat, or tell my friendly voice assistant to turn on the lights or water the lawn. In fact, just yesterday, I saw a commercial for a conversational faucet, if you can believe it, where I could simply tell it to measure out a cup and a half of water as I'm putting together a recipe. So, conversational AI has become commonplace and common knowledge with consumers. And yet, it's not common practice in the enterprise. Business leaders should be asking, why can't we do that with our services? The rest of this talk will focus on answering that exact question, and I'd like to start with a very short video that captures the key value proposition of conversational AI, albeit in a non-technical and some might say humorous fashion.
Hi, 3 for Channel, 2 adults, 1 child.
What the hell is this? George, Elaine and I went to see Channel with Jerry. With Jerry. Great. Probably went to the 84th Street. That's where I always go with Jerry.
Hello, and welcome to Movie Phone. If you know the name of the movie you'd like to see, press 1.
Come on.
Using your touch-tone keypad, please enter the first 3 letters of the movie title now. You've selected Agent Zero. If that's correct, press 1.
What?
You've selected Brown-Eyed Girl. If this is correct, press 1. Why don't you just tell me the name of the movie you selected?
Who knew a show about nothing could make such a profound statement about conversational AI and be a metaphor for the challenges facing traditional applications? Let me connect the dots here. Kramer, the movie phone imposter, represents the traditional application, sometimes hard to learn and frustrating to use. George, the caller, represents the traditional user who's grown accustomed to conforming to the needs of the technology he's using. Now, everything comes to a head when Kramer runs into trouble trying to imitate the crude dictates of traditional applications, and at that point, he's forced to abandon his charade and switch to a conversational approach to understand George by asking, why don't you just tell me the name of the movie you selected? That's conversational AI in a nutshell. Users can just tell the application what they want, and the application will figure out what they're asking and make it happen. With conversational AI, we're able to build solutions where technology will conform to the human rather than forcing humans to conform to technology. Think about how that transforms the traditional application experience. Instead of having to understand how a website's organized or having to master the complexities of an application user interface, users simply engage in natural conversation with applications. Okay, now that we understand what it is and why it's so valuable, let's take a look at how conversational AI can be applied to transform your business. If you look at your typical organization, you'll see that it engages with a variety of different audiences across a variety of different touchpoints. Using the Microsoft Conversational AI platform, every touchpoint in an organization is an opportunity for a conversational experience. You can think of this as ubiquitous conversational AI, and when applied across the board in an organization, it extends the conversational capabilities to the entire organization, which means that end users can engage in conversation with your business and just tell you what they want. That's transformational. So let's unpack that a bit. Speaking of touchpoints, let's start with the traditional website. Every organization has one, and they typically are a one-way conversation. Websites' visitors are primarily looking for information, and embedding a chatbot in a web page is probably the most well-known use case of conversational AI, but it's really important to understand that it's not the only possible use case. Each of the touch points you see surrounding what you can think of as Microsoft's Conversational Hub is an additional conversational AI use case. For example, take messaging clients. These are things like Teams, Skype, Slack, Facebook Messenger, and many others. People use these messaging clients to talk to other people, so it's totally natural and only fitting that people should be able to talk to bots the very same way. Bots built on the Microsoft platform will appear on those messaging platforms the same way people do, and you can talk with them just like you would any other user. Applications are another touch point, and for many, it may come as a surprise that not only can conversational AI be integrated into consumer and line of business applications, but the synergy of conversation and rich user experience creates a brand new category of application that could be called conversational applications. Now, if this sounds intriguing, you can learn more by checking out a short video that describes this new category of applications, and it may even spark a few ideas on how conversational applications could transform your apps. You can watch this video at aka.ms/CAPPS. Okay, moving on. Voice assistants are a very popular touchpoint with consumers and are becoming an increasingly important channel for engaging with customers, and the Microsoft Conversational AI platform allows organizations to build voice assistants for Amazon Alexa, Google Assistant, and Cortana. While not as cutting edge as a voice assistant, phone and email are no less important as a touchpoint for organizations. A great deal of customer engagement is still conducted by phone and email, and being able to call or email a bot provides an enormous amount of business value, especially for organizations that have call centers and help desks, where some estimates are between 40 and 60% of those conversations could be handled by a bot. In fact, bots can actually be used to replace the type of legacy telephony experience that Kramer tried to use in that video I shared earlier. With bots, callers simply say what they want instead of the traditional type of experience where callers hear press 1 for X and press 2 for Y. Finally, the Microsoft Conversational AI platform allows conversational experiences to be built into devices. While most organizations won't have a need to build conversational device experiences, for those that do, this can be an incredibly valuable capability. All right, so that's ubiquitous conversational AI. Let's shift gears now, and we'll take a look at the anatomy of a conversational AI solution. What are the various elements, and how do they all fit together? Let's go through this diagram from left to right. So I'll start with user input, or as I like to think of it, the conversational canvas. We talk about type, tap, and talk as the various modes of user interaction that the Microsoft Bot Framework supports. Type is the most basic form of interaction, and it's the traditional interaction style for bots that most people are familiar with. We also support a much richer form of interaction that we call adaptive cards, which allows what you might call mini web forms in the conversational canvas, and they make the user experience much more productive and less error-prone. Let me drill in on this a quick second. I've browsed to the Adaptive Card Designer, which is a web-based tool that you can use to create rich and engaging user experiences in the conversational canvas. This first area you see here is the Visual Designer. It lets you see exactly what the card you're designing will look like when it's rendered in the conversational canvas. Over to the right, we have the Property Editor. You can use it to set the properties of the various visual elements in the card. Down here on the bottom is the Markup Editor. Adaptive cards are expressed in JSON notation. As you can see in the editor here, the JSON declarations are considered adaptive card markup, if you will, similar to how HTML is markup for web pages. When you're finished designing your card, you simply copy the JSON definition to your app and you use it to render the card in the conversational canvas. Next to it is an editor for data templates. Data templates allow you to separate data from markup. Just like the card markup, data templates are plain old JSON, except in this case, the JSON describes a data object. And the way this works is you embed data template expressions in the adaptive card markup where you want the corresponding data to be substituted. So take the title property here in the data template. To embed this over in the markup editor, you use data binding syntax like you see here. and this data binding acts as a dynamic data placeholder, and it will be replaced by the corresponding runtime data value when the card's rendered. And finally, we have the toolbox over here in the top left. This allows you to have a drag and drop visual design experience. So I can grab any one of these elements and simply drag it onto the design canvas and quickly and easily design a card like this one from scratch. Now, sometimes building from scratch is exactly what you need to do, but other times it might be nice if there was a library of samples that you could look through to find pre-built cards that you could use as a starting point. That's exactly what this sample blade is for. I've opened the sample blade in another tab to make it easy for me to go back and forth between it and the designer. You can thumb through this list of samples here on the left, and as you click them, take a look over on the right and you can see what it looks like. Now there's a decent number of samples here, and if you find one that's reasonably close to what you're trying to design, you can use it as a starting point. For example, I'll click the weather sample here. Now this is a great starting point if you're looking for strong graphic design that involves images and fonts arranged in a way to draw your eye to the important information that you're trying to communicate. When you find the card you want, you can copy the card markup and the data template and just paste it over in the designer, and voila! A snip here and a tuck there, and you can quickly build a high quality card with much less effort. Let me show you what I mean. If I had more of a line of business scenario, I might be drawn to the flight update card. This is a good example of a business-oriented adaptive card that's very tastefully designed. It uses images and fonts and colors to communicate information quickly and clearly. Let's use this sample to show how you could use this as a starting point. The first thing I need to do is to copy the card template here. And now I'll flip back to the designer blade and paste that card definition in right here. And as you can see, it updated the designer, and now you can rework this starting point into the card you want. Notice though, the data expressions aren't rendering properly, and that's because we still need to grab the data template. So let's go do that now. I'll flip back to the samples blade, and now I'll grab the data template this time. I'll flip back to the designer and paste that into the data template editor. And now the card renders properly. From here, I can remove stuff I don't want, or add new stuff by dragging in new items. And I can use the property window to change the settings of any of the elements on the designer. Okay, that was a quick look at the adaptive card designer. Now let's take a look at adaptive cards in action. I'm going to open up a new tab here and browse to an adaptive card demo site. This is a sample bot that showcases adaptive cards and their ability to create uniquely rich and effective conversational experiences. It starts with a welcome prompt that immediately lets the end user know how the bot can help, and in this case, provides a way to quickly start the conversation with a book scuba trip button. So I could click that button, but Conversational AI allows me to just tell the bot what I want. So I could also say, I'd like to book a scuba trip. And the first thing we see is a carousel control, which is very helpful for displaying a large number of results in a small amount of screen real estate like we have in the typical conversational canvas. I can use these chevron buttons here to navigate back and forth through the results. I want to see some turtles, so I'll use the button this time and select this one. So here's a nice pick list with images and fonts. I'll pick the middle one here. Okay, here's an example of a numeric entry field. I have a lot of friends I want to bring on this trip, so I will enter in 7. Adaptive Cards supports field level validation, so I'll have to vote one person off the island here and enter 6. Adaptive Cards has a rich set of controls bot developers can take advantage of, so here's a nice calendar control. Here's some radio buttons. Here's an example of what a mini data entry form looks like. I'll quickly fill this out. So just as we saw before, the email and phone number fields could have field level validation if you like. Finally, we see a nice summary page that confirms the data I entered, and it even lets me check the weather forecast for my trip. Okay, Now let's talk about channels. Channels are the pathways that users take to reach your bot. Earlier, I mentioned a few of those channels like Facebook Messenger, Teams, and Slack. We have more than a dozen channels, and the list will continue to grow, so great support there in that regard. So it turns out that channels do more than just connect users to bots. Channels rationalize the message format of the client so that we can have a single bot that can converse with any client. This means if you want to support Facebook Messenger, Teams, and a web chat client, you don't have to create 3 bots. You create a single bot, and the channel does the work of rationalizing the message that flow to and from the bot. However, if your bot needs to know what channel it's talking to, it can. For example, if you need to provide an elevated experience for, say, Facebook Messenger, you could detect the channel being used and conditionally provide a unique response and experience. Speaking of experiences, those channels can be used to support a wide variety of user experiences. The Scuba demo showed the web experience, which is what most people think of when they think of bots. And as I already mentioned, the bot service also supports messaging clients like Teams, Skype, and Slack, which are specifically designed to allow people to chat with each other via messages. What many people aren't aware of is the Microsoft Bot Framework also allows you to create conversational applications. I mentioned conversational applications earlier. This is the approach that allows users to just speak to an app. They represent an exciting new opportunity for enterprises and organizations to extend natural language experiences to line of business applications and consumer-facing mobile applications, which could then be distributed in an app store. The short 8-minute video I mentioned earlier at aka.ms/CAPPS walks you through the various ways conversation can be woven into an application and should spark some ideas on how you could leverage this exciting new capability. Voice assistants like Alexa, Google Assistant, and Cortana are also experiences now that are supported by the Microsoft Bot Framework. And the newcomer in this group is the telephony channel, which will allow you to create a much richer experience for phone-based conversations than is possible currently with traditional telephony solutions. With the telephony channel, conversation replaces the old keypad-driven menu experience. All right, anatomy-wise, we've now worked our way to the bot itself. User messages flow from the client through the channel and then onto the bot into something we call the assistant. Now, up to this point, we've really only been talking about plumbing. That is, how a message gets to the bot and back again. That's important for sure, but it's not actually the hard part with bots. The hard part is understanding the user and responding appropriately. That's the job of 3 important elements of the assistant: language understanding, Q&A maker, and skills. Let me lightly drill into each one of these. I'll start with our language understanding service. It's an Azure Cognitive Service that we call LUIS for short, and it has 2 primary capabilities. 1, understand what the user means, no matter how they phrase it, and 2, extract the important details from what the user said, no matter where it occurs in the sentence. Now, this is super important since there are any number of ways in casual conversation that users can express themselves. Now, that may sound a bit like Mission Impossible, so let me show you how this works. I'm here in the LUIS portal, and I have a single LUIS application called Pizza Ordering. Let me drill into this application, and here we are. Now, I'll be honest, there's a lot to understand with LUIS, so sticking with the 2 primary capabilities I mentioned will give you a good sense of what our language understanding service is all about without overwhelming you with too many details. I'll go through these one at a time. So intents is the first concept I want to talk about. That's what you see here in the middle of the page. You can think of intents as scenarios you want your bot to be able to handle. So for pizza ordering, that could mean take an order, confirm an order, cancel an order, and if properly greeting your customer is important to you, then you can add an intent to cover that scenario as well. Okay, let's move on to the second important concept now. Entities are words and phrases you want extracted when intents are recognized. There are several types of entities, and we see 3 types in the LUIS application here. Let's drill into the toppings list entry. Lists teach LUIS exactly which keywords to look for in what the user said. So if it's not in the list here, or mentioned as a synonym here, LUIS won't match the entity in the words that the user spoke. This may sound harsh, inflexible, and not very sophisticated, but actually, known keyword anchors like this are very useful in boosting what's called signal, which helps Lewis recognize intents. Let's go back to the full list of entities here so I can show you a machine-learned entity. Let's drill into the order entity here. This is a machine-learned entity, which means that Lewis is taught to extract these entities through a set of examples. Here, natural language processing techniques are used instead of hard-coded lists like we just saw. This natural language processing technique allows Lewis to recognize entities it hadn't specifically been trained to understand. So you can see here that this machine-learned entity is being taught how to pull out important elements of an order. I'll flip back to the main list here, and I'll mention the last type of entity shown here, which is called pre-built entities. These are things like numbers, as you can see here, or dates, or money, or points of interest, names, things like that that are well known and well understood that Microsoft didn't want you to have to create from scratch yourself. So you're welcome. So let me show you how intents and entities come together to make magic. I'll go back to the intent list and drill into the take order intent. What you're looking at here are the training sentences for this scenario. These training sentences teach Lewis how to understand what the end user is saying. If you look at the colorful markup under each training sentence, what you'll see is that the sentence is actually being broken down into its constituent parts. These parts describe a pattern of speech that you expect to see. Let me open the Model Explorer here so you can see what I mean. The order entry is a composite that shows the expected structure of a pizza order, and if I expand it, you can see even more nested structure. Each of those structural elements is a label that can be used to quickly and easily make training sentences that are good examples of what you can expect the bot to be able to understand. This doesn't mean that you need to create every possible training sentence someone might say. Quite the contrary. Lewis uses natural language processing techniques to learn from these structures and patterns so it can correctly recognize legitimate conversation it's never seen before and use the entity information in those labels to extract out all the important information from what the end user says. Let me show you what I mean. So this is the portal test pane, and I can use it to test how well this Lewis model recognizes a pizza order. Let's give it a try here. I'll paste in this example order, which has lots of structure to it so you can see entity extraction in action. Now, as you can see here, the recognition confidence level for this intent is 100%, which is not surprising since I picked this example from the training sentences so we could explore the structure of the results. To do that, you click the Inspect link over here, which opens up the Results Explorer. We started off talking about two central concepts, intents and entities. And I mentioned that entities were words and phrases you want extracted when intents are recognized. And now we're looking at both of those concepts in this Lewis result. Lewis is 100% sure it knows the intent of the user's sentence here, and it's extracted all the data we asked it to. Let's expand these entities Lewis found, and we can see how, piece by piece, the value and subvalues were parsed out and assigned to each of their corresponding entities. And all of this then is handed to your custom bot logic to do with it whatever it wants. So you could use entity details like this to drive an Azure search query, or to extract details of a requested stock trade, for example. Or in this case, pull out all the details of a pizza order your telephony bot took over the phone, allowing your workers to simply focus on efficiently filling orders. Nice, huh? So I mentioned that I cheated and grabbed that pizza order from the training set so I could show you a set of deeply nested entities. Let's try a new one here that I just made up myself. I'll paste this in here, and here's how it reads. I want one small pizza with extra cheese and a side order of fries. Give me another large pizza, half bacon, half pepperoni. Notice that the order itself is a bit of a run-on sentence, and there's a misspelling of the word pepperoni there. As you can see, surprisingly, Lewis is 100% sure this is a take order intent, and it's pulled out 3 entity phrases in spite of that misspelling. And let me fully expand these nested entities here so you can see the detail that it extracted. Pretty amazing. Okay, that was a quick look at our language understanding service, but that's not the only natural language processing service that Microsoft offers. A very common pattern in conversational AI is the question and answer pattern. Because it's so common and well defined, we've been able to create a highly specialized service we call Q&A Maker. It's handcrafted and built from the ground up for this specific Q&A pattern. Let me show you what I mean. So I'm here in the Q&A Maker portal, and this is where you'll go to create what's called a Q&A knowledge base that holds a related set of question and answer pairs. So I've drilled into a knowledge base that I've created, and you can see that it's very straightforward. Questions are in the left-hand column, and answers are in the right-hand column. The natural language processing capabilities of Q&A Maker allow it to infer or deduce what users are asking when their questions don't exactly match the training examples you see here. That's really helpful since in real life, questions can be asked in any number of different ways. Take this question here, for example. How do I raise a bug? Now, if I open Q&A Maker's test tool and drop down here to the message field, I can paste in this question. I have a bug I'd like to report. Q&A Maker is able to infer the correct answer, even though the two sentences are a good bit different. This is natural language processing in action. Sometimes the variation in a user's question is too significant and Q&A Maker won't be able to correctly match it. For example, if I ask, where do I go to report problems? We can see that Q&A Maker can't make that match. Let me ask another variation that won't match. I'll ask, I have a problem I'd like to submit. To address this issue, you'd add an unmatched question as an alternative phrase. Let me show you that now. I'll close this test pane here. I'm going to scroll back up to the top so I can work on that first question. So here's where you go to add an alternative phrase. I'll add that first non-matching example we saw earlier as the alternative phrase for this question. Now that I've added it, I'll save and train. Now if we try that question, Q&A Maker not only recognizes the alternative question we just added, but it also recognized the other variation that it didn't match earlier when we tried it. So you don't need to put every variation of a question in as an alternative phrase. The act of adding one alternative phrase will cover a whole new set of similarly worded variations. Finding these alternative phrases is the type of ongoing training that's common to all artificial intelligence solutions, and it's an activity you perform on a regular basis for your Q&A knowledge base. To make this process as quick and painless as possible, Q&A Maker includes something called active learning that automates the identification of potential alternative phrases based on actual questions that users submit as they use your bot. Knowledge base curators can then easily review these automated suggestions in the Q&A Maker portal and simply click on a button to have them added to the knowledge base. Super helpful, and this would just be part of the rhythm that you'd establish when you deploy your solution. Another useful capability in Q&A Maker is what's called the follow-up prompt. Follow-up prompts allow you to include a set of related questions users are likely to have when this answer is matched. For example, users who ask the question, what is a virtual assistant, might also be interested in what a skill is, so we can include that Q&A pair as a follow-up prompt like this. So I'll give it this display text, and I'll type skill as the search term to filter the candidate links with, and I'll choose this related question as the follow-up prompt to include with this answer when it's matched. Save and train. And now if we ask, what is a virtual assistant, we'll see the follow-up prompt we added. And clicking it takes us to that related answer. The last thing I'll touch on here is how you can import existing Q&A content you may already have. For example, if you have an existing FAQ web page or a PDF document or Excel spreadsheet, all you have to do is to specify a link or upload those documents, and Q&A Maker will parse through whatever you give it and extract out the question and answer pairs. Quite amazing, actually. Here's a URL that I imported into this knowledge base. If I flip over to the web page, you'll see it's just an ordinary FAQ that didn't need to be in any particular format. Okay, so that's a look at how Q&A Maker works. I'm going to flip back to the anatomy diagram now. We've been progressing through this diagram from left to right, and we're now at a point where we can tie all these pieces together and show how a message flows from the user to the custom bot logic. This brings us to the dispatcher. You can think of the dispatcher as a traffic cop that uses Lewis to understand what the user said and to decide how to route that request to the appropriate handler. Now that could be Q&A maker, or that could be a pre-built skill such as mail or points of interest or calendar, or it could be a custom-built skill your organization created. Let's drill into skills a bit. Skills are where the rubber meets the road when building bots. You can think of skills as the subject matter experts of the bot. Skills define the personality of the bot and what make it unique. One bot could have many skills. So an enterprise assistant, for example, might have an HR skill that handles employee conversations like answering questions around pay stubs or vacation balances, and a finance skill could handle conversations related to accounts receivable or purchase orders, for example. A very important aspect of many skills is how they get access to the things they need to satisfy the user's requests. That brings me to the far right part of this diagram where you see iPaaS, which stands for Integration as a Platform Service. iPaaS is what bots use to get connected to the resources and services they need to create transformative experiences. Microsoft is an industry leader in the iPaaS space, so your bot solutions will have seamless and deep integration with your backend resources and services. For example, your bot can leverage things like Azure API Management for creating access to enterprise services, or Azure Logic Apps or Azure Functions to define business processes that skills can then trigger, or integrating with Office 365 or Microsoft Dynamics.
Well, all right. That wraps up a quick introduction to the Microsoft Conversational AI platform from front to back. So at this point, you now understand the big picture, but there is one more important topic we need to address. And I've sort of saved the best for last here, and it's something called the Microsoft Bot Framework Composer, or simply Composer for short. I wanted to end this conversation with Composer since it pulls together everything I've talked about so you can see those concepts in action. And better yet, it's a way for you to quickly get started experimenting and building bots of your own. So what is this Composer? The Composer is a visually driven, no-code approach to rapidly building conversational experiences. I'm going to show you how this tool works and showcase 4 key capabilities that the Composer offers. The first is a visual designer. This is what provides the no-code ability to develop conversational flows. The second is language generation. This is the ability to create natural flowing conversation that doesn't feel robotic. And third is conversational memory. This is the ability to remember all the important details related to a conversation. And finally, fourth is language understanding. This is the ability to understand what a person means, regardless of how they say it. And the best news of all here is that the Composer is a free tool that anyone can download and use to build bots in minutes, as I'm about to demonstrate. You can, and you should, download the Composer by browsing to aka.ms/composer. There, you'll find all the information you need to get set up and start building bots. For this final demo, I'm going to showcase how incredibly easy it is to create conversational experiences using the Composer. To accomplish that, I'm not going to give a detailed explanation of the tool itself, since there are built-in tutorials right here that provide an excellent overview of how to use the Composer. So take a look at that before you start building your first bot. Alright, so this is the Composer's home screen. From here, I can either continue developing an existing bot by choosing from this list, or I can create a new bot, which you can do by clicking the plus sign here. There are a few different ways to create a Composer bot. Templates, like the ones you see here, is one approach, and you can kind of think of these as accelerators for different styles of bots, so super nice. For this bot, I'm going to choose the Create from Scratch option, which generates a basic bot. Since the scenario for this demo is a weather bot, I'm going to name it Weather Vane. There we go. Now I could actually launch this bot right now, and I'd have a fully functional bot that only took me a few seconds to create. But the only thing you'd know how to do is to greet you. So that's where we're going to pick up the story and add our WeatherBot functionality to that. In Composer, dialogues represent the type of conversations bots can have with users. Dialogues contain topics, which define the specifics of the conversation the dialogue covers. The basic bot starts with a single dialogue, which in our case is called the weather vane, as you can see right here. Now at the moment, the only topic this dialogue contains is the user greeting. These topics are triggered in one of two ways, either by events or by something the user said. The greeting you see here is triggered when the conversation starts, and the greeting is the bot's opportunity to give the user a sense of how this bot can help them. You want to create a greeting that narrows the user's expectation of the types of conversations this bot can assist with, and avoid open-ended expectations where users might be tempted to ask questions like, "What's the meaning of life?" I'll click on the greeting conversation here, and we'll see the composer's visual designer. And as you can see, it looks like a flowchart, which is nice. This designer allows you to define the flow of your conversations. Now, since conversations can have multiple participants, the basic bot logic here loops through and greets each user as they enter the conversation. Let me select the send a response activity here. This is how the bot speaks to the user, and if you take a look over to the right, you'll see a response editor labeled language generation. Now, I can simply enter the prompt directly in here, or I could adopt the best practice of factoring them into a function to make the conversational flow a little more readable and maintainable. So let's do that by switching back to the original prompt here, which is called Welcome User. And now I'll navigate to the Bot Response tab where the function definition lives. I'll switch to Edit mode, and then I'll paste in my prompt here. Since I'm building a weather bot that can take a zip code and provide the current weather conditions, I'll set the user's expectation in the greeting with these two prompts. You'll notice that each starts with a hyphen. This tells the language generation engine to randomly pick one of these two responses when responding to the user. If I wanted more variation in the greeting, I could simply add more alternative prompts here. Alright, let's test what we have so far. I'll click the Start Bot button here in the upper right, and Composer will launch a bot testing tool called the Bot Emulator, which is used to quickly test bots in development. Okay, so now the bot's running, and when the conversation started, it triggered the greeting logic we just looked at, which produced the expected response you see here. I mentioned that the language generation engine would randomly pick a response to keep things fresh and less robotic. Let me restart the conversation a few times to show you that in action. Okay, at this point we've seen two of the composer's four main capabilities, the visual designer and language generation. This next part of the demo will cover the last two capabilities, conversational memory and language understanding. Let's take conversational memory first. I'm going to extend the conversational flow of the greeting and personally welcome the user by asking their name and then storing it in conversational memory so I can use it to personalize the greeting. To do that, I'll need to switch back to the designer and scroll to the bottom and click the small plus sign here. This brings up a list of all the things I can add to a conversational flow. And in this case, I want to ask the user their name, so I'll choose Ask a Question and then choose Text as the type of the answer that I expect to hear back from the user. Over here to the right, I can enter the prompt text for the question. So I'll enter, "What is your first name?" I want to make sure I don't erase the hyphen since it's important and it would cause an error if I did. So now we get to the conversational memory part. I've clicked the User Input tab here, which will allow me to specify the user memory variable to hold the user's answer. I'll call it name. Now that we've saved the user's name, we can use it to personally greet the user. To do that, I'll add another action to the flow, and this time I'll choose Send a Response, and we'll enter this response text. Notice the language generation expression there. It'll be replaced with the value we saved in the previous step. And with that, let's give it a whirl. I'll switch back to the bot emulator now and restart the conversation here to pick up the new changes we just made. Great, there's the prompt for my name. Super, now we have a personalized greeting. Okay, so now we'll address the last key capability of the composer, which is language understanding. We want this bot to be able to have a conversation about weather. If you remember, when we first started, I mentioned that in the composer, dialogues represent the type of conversations bots can have with users. And since we want the bot to be able to have a conversation about weather, we'll need to add a new dialogue to cover that. That's done by using this Add drop-down here and choosing Add New Dialogue. I'll call this new dialogue Get Weather, and I'll give it this short description. I'll click OK here, and now we're back in the designer, but now we're designing the conversational flow for getting weather. The next piece is a bit of a repeat. When this conversation begins, we'll let the user know we understood the ask by adding a response action that says, "Sure, I can check the weather for you." Next, we'll ask the user for their zip code by adding a question prompt that says, "What's the zip code?" We'll need to remember that zip code for later, so we'll save that to the zip code property. Now that we have the user's zip code, I can call a web service from the Open Weather service using a token I got for free from the Open Weather site. To do that, I'll add a new action and select Access External Resources, and then send an HTTP request. I won't bother to explain these settings, but if that makes you anxious since you're trying to build this demo yourself, don't worry. At the end of the demo, I'll provide a link to a walkthrough that shows step-by-step how to build this demo so you can make this call work. Okay, now that we've made that call, we'll want to save the results so we can pull out the details we care about. So I'll add another action here to do that by selecting Manage Properties and then Set a Property. I'll save the result to a property I'll call dialog.weather, and we'll pull the content property we're interested in from the result we saved earlier by specifying its content property. Now that we've saved the weather condition to memory, we can use it to respond back to the user and satisfy their request. So let's add a response action. If I scroll this, you'll see a couple more examples of language generation expressions that dig out the weather and temperature information from the result so that we can form the response to the user. Okay, so far we've built a new dialogue, but we haven't specified what triggers this conversation. This is where the language understanding capability comes into play. Let's do that now. I'm going to jump back to the main dialogue here, and I'm going to add a trigger and connect that to the dialogue we just created. I'll call it weather, and I'll paste in these language understanding training phrases. Okay, great. Now we have a trigger that fires this flow when the user asks about weather, even if it doesn't exactly match the training phrases we gave it. Now all we have to do is to trigger the dialogue we want to handle the conversation. We'll do that by adding a new activity and then selecting Dialogue Management and then Begin a new dialogue. Now we simply choose the dialogue we want from this drop-down. Okay, I think we're ready to try this out. I'll restart the bot. Now since we added a language understanding trigger, we'll also need to specify a Lewis authoring key, which you can get from the Azure portal. I'll just paste mine in here. Don't worry, like I said before, the links at the end of this demo will point to the walkthrough that spells all this out. Okay, let's flip back over to the bot emulator. Let's restart the conversation to pick up the new changes to the bot. I'll enter my name. I'll ask about the weather and make sure to vary it so it doesn't match the training phrases. Now for the zip code. And there you have it. A useful bot in a matter of minutes. At this point, we're ready to deploy this bot so that it can be accessed by others from clients like Teams, Facebook Messenger, Slack, Alexa, as well as corporate websites. So that wraps up the discussion of ubiquitous conversational AI on the Microsoft platform. I really hope you found it valuable and that it inspired some ideas on how it can transform your business. I'd encourage you to jot those ideas down, share them with others, try to hone them into a pilot that you could then download and build using Composer. How great would that be? As promised, here are the links that I mentioned. And this first link here is a step-by-step instructions for building the weather bot, in case you want to try that out yourself. I also mentioned conversational applications earlier, so there's that link also. And it might be helpful for you to show others the richness of the client experience on the Microsoft Bot platform, so I've included the Scuba demo link here as well. Well, good luck and happy bot building.